Every single time you click a link, stream a show, or send a message, you are tapping into this massive, invisible web of technology. It's incredible, really. So today, we're going to pull back the curtain. We're going to build that network from the ground up, piece by piece, and see exactly what makes our digital world tick.
I mean, think about it for a second. How is this actually happening? You click a button, and here I am, on your screen. It feels instant, almost like magic. But it's not magic. It's an amazing journey that this data takes. And by the end of this, you'll understand exactly how it works.
Okay, so here is the super official textbook definition from Wikipedia. Digital communications network allows nodes to share resources. You know, it's a bit dry, right? It sounds complicated. Don't worry, we're not leaving it there. We're going to make this way, way simpler.
Let's just forget all that jargon. At its absolute heart, a network is just about one thing: letting computers talk to each other and share stuff. So let's start with the smallest network you can possibly imagine. Just two PCs, hooked together with one cable. Every single thing you do online, from checking email to watching this, is built on this one really simple relationship. It's a conversation, a digital conversation between two distinct roles, the client and the server. So, imagine PC1 needs something that PC2 has stored on it. It kicks off the conversation by making a simple request. Hey, can I please have that file called image.jpg? That's it. That's the first step.
And just like that, PC2 answers back. It hears the request, finds the file, and sends it over. Sure, here you go. That's the whole interaction, a request and a response. Believe it or not, you've just witnessed the core of all networking.
So to put some official labels on it, the client is the one asking for something. The server is the one providing it. In our little example, PC1 was the client. It asked for the image. And PC2 was the server. It served up the file. This simple dynamic is happening millions of times a second all over the world. In fact, you're using a client right now. Whatever device you're watching this on, your computer, your phone, it's acting as a client. It requested this video from a server somewhere out on the internet. It's the same thing when you airdrop a photo to your friend. Their iPhone becomes the client, receiving the file you're serving up.
And here's the really key thing to understand. These roles aren't permanent. A device isn't always a client or always a server. The very same phone that was a client when it received a file becomes a server the moment it sends one. It's all about what action it's performing in that specific conversation, asking or providing.
Okay, so connecting to computers is simple enough. But what about a real-world scenario, like an office with 30 PCs, or even just your home with a few laptops, a smart TV, and a printer? You can't just have a tangled mess of cables connecting everything to everything. You need a central hub. You need a switch. So when we connect all these devices in one place, we create what's called a local area network, or a LAN for short. Just think of it as your own private digital neighborhood. Everything in your house or your office is on the same LAN. And the piece of hardware that makes this neighborhood work is the switch. A switch is like a super efficient mail carrier for your office. It knows the exact address of every single device plugged into it. So when your PC wants to send a document to the printer, the switch delivers it directly to the printer and nowhere else. It's smart. But its knowledge is strictly local. It knows everyone on your street, but it has absolutely no idea how to get a letter to another country. All right, so our local network, our LAN, is buzzing with activity. But right now, it's basically a digital island, completely cut off from the rest of the world. So how do we build a bridge from our private little network to the giant global network called the internet? For that, we need a totally different device. We need a router. This really breaks down the difference. A switch's job is to connect devices inside your LAN. A router's job is to connect your entire LAN to other networks. Its scope isn't local. Its scope is the entire internet. That's why a switch needs tons of ports for all your local devices, while a router only needs a few. It's not connecting individual PCs. It's the one and only gateway between your whole network and the outside world. So let's follow the data on a trip around the world. Your PC in New York sends out a request. First, it hits your local switch. The switch sees the address is outside the neighborhood, so it sends it to the only device that knows the way out, the router. The router then flings the data across the internet. It zips across oceans and continents, arriving at the router in Tokyo. That router passes it to the local switch in the Tokyo office, which finally delivers it to the server, and then the whole thing happens in reverse for the reply, all in the blink of an eye. This is awesome. Our network is built, it's connected, it's talking to the world. But
We have a new problem, a big one. By connecting to the internet, we've basically opened our front door to billions of other devices. We need a security guard.
Let's be real. The internet is kind of like a massive city. There are amazing places and people, but there are also some bad actors out there, constantly looking for unlocked doors. So how do we let the good stuff in, but keep the bad stuff out?
The answer is a firewall. Think of a network firewall as the ultimate bouncer for your entire network. It's a dedicated piece of hardware that stands at the very edge, inspecting every single packet of data that tries to enter or leave. Based on a set of security rules you give it, it decides you can come in or nope, you're blocked.
Now, you've probably heard of the firewall that's on your computer. That's called a host-based firewall. It's software, and it's great, but it only protects that one machine. Think of it like a lock on your bedroom door. A network firewall is like the main security system for the entire house. It's a powerful appliance that shields every single device inside your LAN.
And this technology just keeps getting smarter. The first firewalls were pretty simple. They just looked at addresses. But modern next-generation firewalls are way more advanced. They can actually understand what applications people are using and can even peek inside the data to spot sophisticated attacks before they ever get a chance to do any damage.
So as you're sitting here watching this, just think about that journey. Your device is the client, a server somewhere out on the web is providing the data, and in between, an entire team of switches, routers, and firewalls are working together at light speed just to make this seamless connection happen. It's this beautiful, complex dance of technology that's happening all the time right under our noses. And hopefully, it's not so invisible anymore.